research review. So we're doing what is funny to call a throwback because it's only 6 months old, but it's about AI. So, that's 6 AI months ago, which is like, I don't know how to convert to real months, and I don't want to speculate any further on those conversions. However, we have Pwning Claude code in 8 ways. So I might have done a negative episode on this, pre-negative episodes. Maybe not. I know I've read it, but I need to go back through it. We're not necessarily gonna get into never ask a research reviewer why he reviews his research. So Pwning Claude code in 8 different ways by RyotaK. RyotaK. Man, I can't learn how to say things good. Oh well. Introduction. Hello. I'm RyotaK, a security engineer at GMO Flat Security Inc. A few months ago, I came across an interesting behavior while using Claude Code. It executed a command without my approval. Since I wasn't using the permission bypass mode, I decided to investigate further to understand why it was able to execute commands without explicit approval. TLDR, I discovered 8 ways to execute arbitrary commands in Claude Code without user approval. Claude Code allows users to control which commands can be executed either via an allow list or manual approval. Several read-only commands were allow listed by default, such as echo, sort, and sed. To prevent side effects from these read-only commands, Claude Code implemented a block list mechanism that blocks certain patterns and command arguments, even for allow list commands. However, there were multiple flaws in this block list mechanism that allowed me to bypass it and execute arbitrary commands without user approval. CVE 2025-66032 is assigned for these issues, and they are fixed in Claude Code v1093. So obviously, there's a lot to think about here. It's like, dang, that's some gnarly behavior, and just like trying to have, blacklists to prevent bad behaviors is always, there's always some CTF player working around your regular expressions. So what immediately stands out to me is like a lot of the times like the BSD implementation of these like core utils will be different than the GNU one, and the GNU core utils implementation will support like some just like embrace, extend, extinguish GNU garbage, and so like, and then maybe how do you even, if you're writing the like blacklists for which flags can be used for these like approved core utils commands like that are supposed to be read only, how do you even know what the implementation is? Like there's no like standard. So like I guess like you probably want it to work for like popular common distributions like BSD core utils and GNU core utils, and probably that's so confusing, like weird busybox implementation that I don't even know like that's confusing to me. I don't know like where the line lies on like, no dude, that's not a set implementation anybody would ever have on a real system versus like whatever. So this already seems like a bad idea. I sure hope no other of these tools try to implement something like this, because seems like a really bad game of whack-a-mole with no clear lines on. There's no such thing as a like standard set implementation or whatever. It's just like what binaries happen to be on the box, and what gnarly source were they built from, and why is it somebody's GNU fork that adds, I don't know. Oh lord, that's crazy. Alright, Claude Code's permission model. Claude Code provides 2 ways to control command execution: an allow list and manual approval. The allow list allows users to pre-configure which commands can be executed without approval. For example, if touch is allow listed, Claude Code can execute touch/temp/hacked without user approval. In addition to the allow list, Claude Code provides manual approval for commands during the conversation. When a command is not allow listed, Claude Code asks the user for approval before executing it. Bug bounty hunters, when they see the Claude prompt and are like, dude, what's that? I just only use dangerously skip permissions, and then wonder why their boxes get shelled. Is that too far? I don't know. Too soon? Funny. To achieve a smooth user experience, Claude Code allow lists several read-only commands. Oh yeah, read-only commands, yeah. By default, such as echo, man, sed, dude, man, sketchy. These commands are considered read-only because they typically only read data and produce output without modifying the system state. This was implemented using regular expressions like the following. Dude, never give this guy a regular expression-based blacklist. Like you've already lost yeah, especially for command execution. However, as you might imagine, this approach is prone to mistakes. I found multiple vulnerabilities in this blocklist mechanism that allowed me to execute arbitrary commands without user approval. Yeah. 1 through 3. Failing to filter dangerous arguments. And see, this is where it's like, what even is a man implementation? The first vulnerability I found was in the man commands block list mechanism. The regex above is intended to block arguments like -P or --pager, which allow users to specify a custom pager program, potentially leading to arbitrary command execution. However, there's another dangerous option called -HTML that allows users to specify a command to render the manual pages as HTML. This option can be exploited to execute arbitrary commands. Nice. It's just free. Since man is an allow listed command, Claude Code recognizes this command as a read-only operation and executes it without user approval, leading to arbitrary command execution. The second vulnerability was in the sort commands block list mechanism. It used the following regular expression intended to block the -O or -output option. Similar to the man commands case, the -compress program. That sounds like some GNU implementation. Like if anybody's, you know what? Let's GNU sort man page. Is this for the GNU one? And then BSD core utils sort. Like I want to see the difference. No, come on, man. Is this for GNU? I want the GNU sort. Maybe I need the GNU info page. Okay, that one's GNU core utils. Is this? Alright. Like, here we go. Okay, so it looks like this is for, I don't know if this is BSD core utils, but this is like the free BSD. I don't know. I'm sure they probably use BSD core utils. But if you look at the GNU implementation, you'll see this nonsense. Like, of course. But if you're using a real implementation, it doesn't have that. Why would it support that? That's crazy. Now, don't get me wrong. I think most systems are probably like most Linux systems that people are actually using are probably shipping with GNU core utils. And so this is definitely very valid. But it's just like, it's so silly. Especially if they like wrote it on a Mac that, I don't know, I don't even know. I don't want to think about Apple. Not thinking about Apple. But yeah, so it's just such a silly space to live in. And I'm glad that Anthropic was able to pay out for these and understand the risk, though, because it is, yeah, these are good bugs. But it's just such a silly game to be playing. Like, why did they build this way? Right, so, yeah, you can just pass compress program and it'll run a binary, or, it'll just, like, pass it to, like, system or something. Ooh, you can fit, like, full. To tackle this, we can leverage the fact that sort writes the string being sorted to the standard input of the specified program. Okay. By using a shell like sh as the compression program, we can pass commands via standard input. That rules. I really like that trick, because it is just, like, you know, it's just running something it finds in the path versus... Nice, and then we can send a standard in and actually get code execution. The -S1B option limits the main memory buffer to 1 byte, forcing sort to use temporary files. Oh, that's so cool. And invoke the compression program during the sorting process. See, alright, these are really good. I like it. Third vulnerability was in the history command. The -S option adds the given string to the history list as a new entry. Nice. The -A option then appends the current session's command history to the specified file, allowing us to write arbitrary content to any file. Yo, that's really funny. I need to show my friend that. He used to prank people that would leave their laptops unlocked with catting their... He'd run history and just append it to their bash RC, which is like... I mean, that is so evil. But this is really funny, using history to write to the bash RC. Wow. I'll have to show him that trick. He doesn't even need to call cat. He can just use -A. When the user starts the new shell, the injected command in .bash RC will be executed. That's actually hilarious. Man, I've definitely had that happen to me once. Which is why, if you're ever around me, you'll notice I'm pretty good about locking my laptop. Gets ambiguous command argument. Oh man, this is, jeez. The above three vulnerabilities were due to an oversight of dangerous arguments in the blocklist mechanism. However, there was another case that filtered out dangerous arguments but still allowed arbitrary command execution due to Git's behavior. Yeah, that's to be expected. Like, I'd be shocked if there weren't Git problems in a lot of these. The following regex was used to filter out the --upload pack argument for the git ls remote command. However, because Git parses abbreviated arguments, it was possible to bypass this filtering by using --upload PA instead of upload pack. This is possible due to the following logic and Git source code. This is why top 10 favorite researchers, RyotaK is on there probably. Like that, like the fact that I don't even have to sit and beg for a source reference and he's got it. It's like, dude, that's so good to see the source reference here and be able to see, wow, that is very interesting behavior, and that it's being implemented this way. The code compares the first n characters of the option name, where n is the length of the user-provided argument, using stir n comp. If the prefix matches, Git considers it a valid abbreviation of the full option name. Therefore, --upload PA is treated as upload pack, allowing us to execute arbitrary commands. Nice. Executing the above command leads to the execution of touch temp pwned without user approval, as upload PA is recognized as upload pack by Git, bypassing Claude Code's block list mechanism. Nice. Seds E command to execute arbitrary commands. Command line arguments are not the only way to execute arbitrary commands. Some commands have built-in features that allow command execution. One such command is sed, which has a modifier called E that allows users to execute shell commands from within sed. From the GNU sed manual. Okay, there we go. There's like official GNU manuals. Or can I get the GNU info on this actually? Yeah, that's cool. Can you just get like, yep, okay. For example, the following, the command allows one to pipe input from a shell command into pattern space. If a substitution was made, the command that is found in pattern space is executed, and pattern space is replaced with its output. For example, the following sed command will execute touch temp pwned. So just sed/s/test, echo test, replacing test with that, because it has /e at the end, so it's like we're running the replacement piece, which is, that's interesting. The regular expression for sed, that's actually, oh man, the regular expression for sed was as follows. The above command also bypasses the block list mechanism. Cool. 6 through 7, different interpretations of command arguments. The following vulnerabilities are a bit more complicated than the previous ones. They arose from different interpretation of command arguments between Claude Code and the commands themselves. For example, the following regex was used to filter out dangerous arguments for the xargs command. Good luck. The regular expression ensures that commands executed via xargs are limited to echo, printf, wc, grep, head, tail. The regex expects that all command line arguments consume a subsequent value, so it allows an arbitrary string to be placed after each argument. However, some xargs arguments do not consume a subsequent value, causing the next argument to be interpreted as the command. For example, the -t option, which prints each command to standard error before execution, is a flag that takes no value. So xargs-t touch, it's like, yeah, you're running touch, that's cool, you're allowed to do that. Then you run something else, actually. Or it thinks that that's being consumed. Okay, yeah, that makes sense. It thinks that's being consumed by this, and it's like, yeah, you're running echo, and it's like, nah, man, you're actually getting touched. So, in this command, Claude Code's regex interprets touch as the value for -t, and echo as the command to execute. However, xargs actually interprets -t as a standalone flag, and touch as the command to execute, with echo as an argument to touch. Yeah. Due to this behavior, Claude Code fails to detect that the above xargs command is executing touch instead of echo, allowing a maliciously crafted xargs command to bypass the permissions prompt and achieve arbitrary command execution. Nice. Similar vulnerability was found in the regular expression for the ripgrep command. Regular expression ensures that the RG command consists of arguments without values in a search pattern. However, because the regex uses to match the search pattern, it allows arbitrary strings without spaces. This allows us to use the IFS variable, internal field separator, as a shell variable that defines the characters used to split strings into words. By default, it contains space, tab, and new line characters. When the shell expands IFS, it becomes a space character, but since IFS itself contains no spaces, it matches the regex, not that, which means Claude Code still considers it a valid RG command. Yeah, this is really helpful. And then the alternative where you like wrap it in curly braces if you don't get to have nice stuff in front of it. But that might not necessarily match the, I don't know. The -- pre option in ripgrep specifies a preprocessor command on each file before searching. When a preprocessor is specified, ripgrep executes the command with the file path as an argument and uses its standard output as the search target. Okay. By setting --pre equals sh, grep executes sh for each file, which causes the shell to interpret the file contents as a shell script. Since the .claude projects directory contains previous Claude code conversations, an attacker can embed command substitution, such as in the conversation. When sh parses this file as a script, it executes the embedded command. I wonder if there's a better... I'm sure he tried to come up with ways to deliver it that didn't require that, just from... That's really cool. I like that. And also, funny flag to have. This one is my favorite, I think, if I remember this one correctly. Bash variable expansion chain to arbitrary command execution. This trick is nuts. So I thought I needed this trick in December, and then I saw this drop, and I'm like, wait, that was actually exploitable. Then it turned out I was looking at something that did sanitization with rules similar to this, and the thing is, it wasn't reaching a dangerous sink. I think historically it may have, but it wasn't reaching one anymore. So anyway, get into what this is. The above vulnerabilities targeted the block list mechanism for individual commands. However, I also found a more generic vulnerability in how Claude Code parses commands. When parsing commands, Claude Code fails to properly filter out Bash's variable expansion syntax. Bash variable expansion is written as var or var, and it allows the user to reference the value of variables. While this sounds harmless, it can be abused to execute arbitrary commands by chaining multiple variable expansions together. This became possible because variable expansion supports the @p modifier. So this is like the, what is this? Dang CTF players, which parses the value of the variable as a prompt string. In Bash, the prompt strings, like those used in PS1 for the command prompt, support special escape sequences, including command substitution via escaped $ stuff. While @p is applied to a variable, Bash interprets its value as if it were a prompt string, executing any embedded command substitutions. Since was blocked by Claude Code, I had to chain multiple variable expansions together. So he has 1 equals $, 2 equals 1, and then that, so it's legal, and then he performs the expansion on that. That's so cool. That makes perfect sense, and that's such a cool trick. I saw this exact scenario where, it blocked backtick, it blocked a bunch of other shell meta characters, it blocked this one, but you could get this. But unfortunately it wasn't reaching a dangerous sink, otherwise I would have gone back to it with this trick. Executing the above command sets the variable 1 to $, then sets the variable 2 to 1 touch temp pwned, which expands to touch temp. Finally, 2 @p parses the value of 2 as a prompt string, leading to the execution of touch temp pwned. That's awesome. Since Claude Code fails to recognize the variable expansion syntax, it treats this command as a simple echo command, which is allow list, and executes it without user approval. Conclusion. In this article, I explained 8 different ways to execute arbitrary commands in Claude Code without user approval. These vulnerabilities could be exploited by attackers to compromise systems via indirect prompt injection, where malicious instructions embedded in files or web pages caused Claude Code to execute unintended commands. Anthropic was very responsive and addressed these issues by introducing an allow list approach instead of the previous block list approach. This was the core core architectural failure. These vulnerabilities were assigned CVE and fixed in Claude Code. I hope this article highlights the importance of favoring an allow list approach over a block list approach when implementing security-sensitive features like command execution. I think that is the big takeaway here. Shameless plug. At GMO Flat Security, we provide top-notch penetration testing for a wide range of targets, including web, mobile, cloud, LLM, and IoT. There's their link. We also developed Takumi, our AI security engineer, built by world-class offensive security experts. Takumi brings human-level reasoning to application security using a hybrid AI-powered SaaS approach. Wow, I want that. It audits your code and live apps. I want custom SaaS rules written on the fly for application-specific syncs and sources. It audits your logs, your code, and live apps to uncover everything from classic vulnerabilities to logic flaws like broken authentication and authorization, all validated through safe exploit simulations for near zero false positives. These guys are doing really good work, and they have some really, really good people. So, right. Okay. So research review piece of this. Where's the checklist or the format? All right. How does this generally apply to bug bounty? So there's two kind of bigger ideas here. So definitely that case of trying to use blacklists to prevent dangerous things in rich contexts. I mean, that is such a bad design decision, and you're going to have a ton of bugs and a ton of bypasses, and all you need is goofy GNU implementations when you wrote it on Mac with like BSD core utils where, dude, I don't know, man, I like looked at the supported flags and there was no -- compress program, and then it's like, oh nope, somebody's running it on a normal Linux distro using GNU core utils, and you get owned. Why did this work? I mean, this is a perfect example of like cracked CTF player versus CTFE application. Identifying that this was like very interesting behavior to look into, and seeing what was going on and being like, nah, there's no way this is secure, and then finding out, oh yeah, there is no way it's secure. Further research that should be done here. I think it's always interesting to stay on top of how these anytime that there's like safe whitelisted or like, so they moved to a whitelist model, but is the whitelist actually safe? And I'm sure people have done much more further research on this. This is an article from January. I really like that shell trick. That's so cool. I wonder how they prevent it. Do they just block @p? And if so, are there any other like things you can use in bash that lead to shell expansion? Conclusion, I mean, I think he concluded for us. Rating, I rate this 2 @p out of 10. So hopefully there's no shell meta characters being expanded there. Hopefully I didn't just get RCE'd. I think that hits the points, definitely. I mean, FlatTech posts crazy research. RyotaK is cracked, and I think he has some newer one about some dependency hijacking or something in Claude. I like glanced at it and was like, I want to see this. I like the really like cool CTFE like tricks. Like, I mean, this rules so much. So I think we've covered everything and the research is reviewed.